you should be able to do these things. So let's assume that I have some string example. Let's do a new string example. So we'll do a string example. Okay, that's just fun. Let's have some fun with strings. And we'll do a PSVM Control J enter, and we'll make a string called run. Oops. The string R equals quote run. And we know now that strings are immutable, which means we cannot change them. And if I want to print out R, I probably could. And if I did, it should print out something like run. Now, what would I want to do here if I wanted to print running? Not just run, but running. Like I can't say I am run, right? That makes no sense. But I could say I am running. So to modify the string, we use one of the few overloaded operators available to us in Java. And so what we can do is we can add, quote, ing. So now I have two different strings. One is run, and the other is ing. Those are both literals, and they will be concatenated using the plus sign. Concatenation means to put together. So now when you go to print R, it should print running. Eventually. So what I'd like to do, I think I need an extra n in there. But it did work, even though it's misspelt. So what I'd like to do is I'd like to say that this string has not been changed. And this string has not been changed. Whoops. But R is actually a third string. So if somebody says, how many strings do you see? The answer is 3. Right? There's the run literal. There's the running. There's the ing suffix. And then there's the R string. And what you can say is that these are 3 different reference data types. They're different. So then you'd say, okay, well, what is the difference between an array of char and a string? Well, an array of char is actually a reference data type. And a string is actually a reference data type. But if I want to know the length of a string, I can go get length, right? No? Get size? Oops. Get size? Forget how to do this. Length, that's it. All right, so now I have the length of the string. So let's see, RUN, NING, that's 7. It probably starts at location 0, so I'll call it 7 elements. Yep, there it is. That works. So now let's assume that you're very interested in this string, and what you'd like to do is you'd like to convert it into an array of char. Now an array of char is a different reference data type. So let's make a char array, CA, char array, equals r dot to char array. Well, that's interesting, right? So now I can go through the char array and I can print out the individual chars in the string. Well, let's see now. I'll need a for loop for that. For integer I equals 0. Now, how do I know the length of the char array? I mean, before I said, aha, r dot length, that's going to give me the length of the string. So what do you suppose the length of the char array is going to be? Because I have to have a termination factor, right? For loops start off with an initializer, but then there's a while loop contained after the semicolon. And it says while I is less than some number, that's got to be the length of the array, right? Then I can continue. And as soon as that's no longer the case, I have to stop, or I'm going to go outside of the bounds of the array, and I'll have an array out of bounds exception at runtime. So how long is this array? How can I tell when to stop? I could use the length of the string, but suppose I was just past this array of char. An arbitrarily long array, I don't know how long it is. How do I determine the length of the array? No joy in Mudville, huh? Do what now? CA.length. So dot length will give me the length of the array, but invoking the length method will give me the length of the string. Two different things. One is a member of the array class, and the other is a method, which is part of the string reference data type. So now I could say I++, and he's giving me a hard time because I didn't write I while I is less than. And now I can print out CA of I, and voila, we should have running printed vertically down the screen. So I can have access to the individual array elements. Remember, in Java, a character is a 16-bit unsigned quantity, a Unicode character, which means there are 2 to the 16 or 65,536 possible different characters, which in some fonts will give you ideographs. So for example, in katakana in Japanese, you might actually want to have 65,536 different possible characters. So if you want a truly portable program, that might not even be enough because some of the ancient katakana actually exceeds the total number of 65,536 because they use little pictures in order to represent words. They don't have a simple alphabetic, well, I shouldn't say simple. They don't have an alphabetic style of language like you might see in Greek, for example, or Hebrew, or English. I don't know about the other languages. I think, does anybody know if Sanskrit is got a lot of characters? How many characters in Sanskrit? Nobody here speaks that, right? Not for a long time. But you should know. I mean, it's not my culture, but you guys, you should know. Because if you don't know, who am I going to ask? Not you, apparently. Okay, fair enough. They don't teach that in the British school system. I don't blame them. Yeah, because it's an honored language, but it's a dead language, right? I mean, but even in this university, I think there must be somebody who knows these things because they teach all these different languages. I bet you there's an ancient languages professor here on campus who would know the answers to this. Somebody, not me. The only language I know is Java. So then, we got to the point where we took a string, we converted it into an array of character, and then I made mention of the fact that a character is an unsigned 16-bit quantity. 16-bit. What is the primitive data type that's a 16-bit that's not a character? A numeric data type. Well, int is 32-bit and it's signed. Short. Short. So suppose I had a short, and let's call the short S, and let's set it equal to CA of I. Oh, he doesn't like that. What do you suppose the problem is? He says this is char and that is short. Well, I know, it'll fit, so trust me, short. I'll cast it. So I tell the compiler to use what I would call strict typing, right? But then I tell the compiler, you know, this is a char and this is a short, and I'm going to equate them. And the compiler says, no, these are different. And I say, I don't care. Just do it. So if you don't like the rule, it's okay. You can override it. If the class cast exception at runtime fails, okay, sorry. If you lose bits as a result, yeah, too bad. You did it to yourself, right? So it's a very powerful gun, casting. If you shoot yourself in the foot with it, don't come crying to me. So now I've got this short, and I've got this char. And I think maybe I can print the two out because they are two representations of the same thing. So let's do that. Plus, quote, colon, end quote, plus. So now what we're going to have is the short representation of the char and then the character representation of the char, and we can see the two things next to one another. How fun. Maybe. And what we should see is numbers are being used to represent characters. So the characters are actually encoded as numbers. Very interesting. Now, suppose I were to take those short characters and encode them. I'm going to write a very fancy encoding algorithm here. Short encoded is equal to short plus 3. Now, he says, oh, this is not working because something or other about casting. So I don't care. I'll just write short, and I'll put it together, and now we're good. So now I've got an encoded version of the short. Right? It's just s plus 3. Now, that's really a different character, isn't it? Different character. So suppose now I go through this process where I've gotten this encoded character, and I want to make an encoded output string, right? My secret message. Ooh, secret message. So what we'll do is we'll create something called a string builder. SB equals new string builder. And string builder is just like the string buffer, which is mentioned in the book, only with a difference. And it's a little bit faster. String buffer has what they call a thread-safe technology behind it, which makes it a little bit slower. So I'll just use this string buffer to make a mutable string object. So before we said strings are immutable, well, string buffers are not. So string buffers are just like strings with a difference. And the difference is you can grow them efficiently. You can surgically alter them. You can do string manipulations to them, which enable you to do parsing, which enable you to do string substitutions, which enables you to get into index of and do all kinds of interesting fancy things and do it efficiently. So the string builder is going to be used to create a long string. And what I'll do with the string builder is I will say sb dot append, and we'll put in the character, char, of se. So we're taking se and we're casting it back to character and appending it to a string buffer. So that when we're done with our little for loop, we're going to have encoded cipher text. So in the world of cryptography, there are two different things that you need to care about. The first is called plain text, and the other is called cipher text. Right? So what we've done is we've taken plain text, which spells out running or whatever message you like, and we're going to encode it using our very fancy offset by 3 encoder, which takes the numeric representation, adds 3, converts it back to a character, and builds up a string. And we'll take that string and we'll print it. S out, Control J, enter, and then SB. So that will do a 2-string invocation on the string builder. And what we will see will be encoded text. That is text which we would not recognize, right? Text which will guard our secret message with its cleverness. Oh, behold the cleverness of my offset by 3 encoder. What is that kind of code called? For those of you who are cryptographers, see, look at that. Here's my encoded text. No one can read it. It says running. Now the big question is, can we decode it? Oh, and did you tell me yet? You know what this is called? What's it called? Encryption. No, but it has a name. What kind of encryption? It's a cipher. It has an eponym. You know what an eponym is? Eponym, that's a name that's known because it's named after a person. For example, Einsteinian notation is named after Albert Einstein. That's an eponym, right? So the ciphertext is named after a very famous general who used it. A general whose name you know. His name is Caesar. And this is called the Caesar cipher. So Julius Caesar used this very cipher. You can look him up. See, there he is. And here is his cipher text, right? And here is the plain text. And what you do is you can see how the letters have been encoded, right, using what's called a simple substitution. Simple substitution. And so this is the case where you can do it physically, where you map the letters by offset. But when you have a computer program, you really just need the ability to add. And if you have the ability to add, you can do a Caesar cipher. I know Caesar used this text, this cipher, this cryptography form, but I don't know that he invented it. Right? It probably predates him. So it's a very ancient cipher. Caesar also used steganography. Jesus, we're going to school here or something. You guys know what steganography is? Graphy means writing. Steganography comes from the Greek. It's hidden writing. Hidden writing. So what he would do, because he was all-powerful, general, emperor, right? He would shave the head of the messenger and write the secret message. And then they'd hang out and wait for the hair to grow back, and then he'd send him off on his way. So it was hidden underneath the hair. That doesn't work if you have a bald spot. And that's hidden writing. So if you can take the message and encode it in an image, that's steganography. And if you can take the image and post it on some public website and say, oh, look, I took a picture of the Leaning Tower of Pisa while I was here in Italy. And then inside it can give you, the secret message that says, we'll be meeting in the subway and releasing the sarin gas. And you're like, oh, boy, this is great. So, you can use it for all kinds of nefarious things. And maybe, I'm broadcasting this now, maybe the NSA is listening now. Well, I can show you how to write some Java to encode your images and with hidden writing. Very simple. So now we've got this lovely string, the encoded, we'll call it the cipher text. Ooh, very, very interesting stuff, right? Now I want to be able to decode, right? Let's decode the cipher text. I've got this text in the string. So let's get the cipher text out. We'll call it char cipher array. And I guess it's an array. So we'll set it equal to sb.get. Can you get the array of chars? Get chars? There should be something that just gets a... I suppose we could just get a string, but I had a feeling there was a way to get chars. Let me just look real quick. Here it says get chars, and it comes back with a char array. So that looks pretty good to me. So we need the source beginning. That's going to be... that just seems very peculiar. Why should it be so hard? I'll just write toString dot toChar array. There, that's easy. I like that better. So I converted the string buffer to a string, then I converted it to an array of char. Now I've got my cipher array. Now I have to write another for loop to decode it for integer I equals 0, while I is less than cipher array dot length I minus minus No, I++. I don't know what I was thinking. And then my cipher array has to be decoded using the same technique that I used for encoding it. So what I guess I'll do here is I'm going to need a, well, let's get the char. char cipher char equals cipher array of I. And I know I need to subtract 3. And then after I subtract 3, I have to add it to a string buffer or string builder. So we'll make a string builder for the decoded text. String builder, we'll call it plain text, pt equals new string builder, new string builder. And now to build this string, what we're going to need to do is we'll have to say pt.append, and we're going to need a character, cc, but that character we have to subtract 3 from. And you think he'll let me do that? What do you suppose pt will print? Sout, Control-J, Enter, pt. Let's find out. Because he didn't complain. CC could be treated as a char. Subtracting 3, however, might promote it to an int. If it's turned into an int and then appended, you could have a series of different integers. And if that's the case, then the overloading on the negative sign is not done what we wanted, but it has done what we specified. See, it's given us the numbers. So what we need to do before we take those numbers and append them is convert them back into chars. And that should do it for us. This will have Caesar running over in his grave there. So now we've got the ciphertext on the bottom, and then the decoded plain text immediately following. What do you think of that? 2,000-year-old encryption technology. Totally insecure, by the way. You can't use this for anything real, but it's okay. So what do you think? That's good, right? That it's fairly well understood. It has its basis in ancient Rome. What's not to like? So I'm thinking that maybe I could write some kind of a subroutine for doing ciphers using encoding and decoding. I kind of have all the pieces together here, and here's my little example. Ciphertext goes in, and, well, let's see now. Plain text goes in, ciphertext comes out. That's encrypt. Ciphertext goes in, plain text comes out. So now I've got plain text going in. Okay. How would I be able to encrypt the plain text? What should I do? I want to make this a subroutine. And the subroutine should be able to take the plain text, encrypt it, and then take the ciphertext and decrypt it. Because if you're going to have a coder, it makes no sense unless you have a decoder. So I want to be able to print the ciphertext and the decoded text. Sout, Control-J, Enter, quote, ciphertext, and decode text, plain text, plain text. Oops. And that will be the decoded text. So how shall we write decrypt? You've seen me do this live here in front of you, in front of your very eyes. What do you think? Any ideas? What shall we do? How do I start? Well, we already know we're going to do the offset by 3 cipher, Caesar cipher. So what do you think? Can we use the string directly? Not directly, because you can't modify it, because it's immutable, right? Immutable strings can't be modified. So I've got to go through the string and either turn it into an array of char or do something else. How about this? How about if I were to create something called a string buffer, right? We've heard a lot about string builders. Let's try the string buffer. String buffer SB equals new string buffer. And the string buffer, I think it can take a little text. Whoops. Darn it. I hate this pad. I wish I could disable the trackpad. So now I've got the ciphertext going into the string buffer. I have to subtract 3 from each element inside the string buffer. Integer I equals 0, while I is less than SB dot length I plus plus. Suppose I went into the string buffer and surgically altered it. I can do that, right? SB dot element at or character at. No, he doesn't like that. How about this? Character at? Oh, character at. I like that. So here's the character at location I. That's good, right? Now I don't need a separate array of string. And now I can subtract off 3. And now I can do SB dot. Is there a way to set character at? There is. And I can use the location. Oops. This is maybe too clever by half. And then the value of char. Put this into parentheses. And when I return SB, I just called toString. And that's it. How's that? So what have I done here? I've gone through the string ciphertext, which was said to be immutable. I promoted it to a mutable string buffer. Then I went through each element in the string buffer as though it were an array of char, which it is not, but it does have an array of char held internally. I accessed each one of the arrays, each one of the chars in the internally held array using the method invocations, subtracted off 3 after converting them into ints, then taking those ints, converting them back to char, and replacing them. So I surgically altered the string buffer. Very efficient. And then at the end of the day, I converted it back to a decrypted string. I can take all of this, copy it, and paste it right in here. And all I need to do is change plain text, ciphertext into plain text, and we are there with a single exception. And because we're encoding the plain text, we have to add 3. Notice what I did. I didn't know how to write a decrypt algorithm. I didn't know how to write an encrypt algorithm, but I knew that I needed these things. So first thing I did was I created the framework, which included returning null. These things had no implementation. Then I proceeded to write the test for the framework. So I started by assuming the existence of these auxiliary helper methods without implementing them. I wrote the test, wrote what I expected them to input, wrote what I expected them to output. Then I proceeded to go through and do some quick prototyping to see if I could create just a single main method in front of you in real time. in order to be able to do the encryption and the decryption, once I had a firm conceptual grasp of how to do Caesar ciphers, I then went back and I was able to quickly implement a very efficient, right? This is a very efficient way to go through with the string buffer and not create a whole bunch of extra stuff. Why? Because if you create a new array, it's going to be as expensive as a malloc in C or a new in C++. It's going to slow you way down when you try and implement this code in a production environment. So doing memory allocations off the heap and making new instances of arrays is a big lose for you. It's going to make everybody think Java is slow, when in fact it's just your programming that's slow. So this is done after you've had what I would call a fairly good grasp of the problem and of its implementation. And hopefully this will work. I probably should have tested it before I went off and started pontificating. Hey, how about that? So the ciphertext is shown. The message comes out later. So here's the ciphertext. Very hard to decode. Here's the message. And now we can make this useful little subroutine to work with arbitrarily long messages like, boy, those Romans were smart. Weren't they? I mean, you just gotta behold the beauty of this very elegant algorithm, which basically does nothing but add, and yet turns the text into something that nobody in that era could have read. You know? And look at this. Boy, those Romans were smart. You can't read that unless you know the technique. Right? So in some sense, one could make a compelling argument that adding 3 is stupid. And why would anybody do that? Because you could easily decode it without knowing the technique. And still, when you look at it today, it kind of looks like garbage. It's gobbledygook. You can't decode that. And yet it's perfectly legit. You could send it in an email, and anyone who intercepts it casually would not be able to decode it easily, unless they have some knowledge of cryptography. How about that? And we were able to motivate a lesson in string builder, a lesson in string buffer, a lesson in immutable strings, and a lesson in arrays of care. How about that?
I still didn't understand why we are adding and subtracting 3 over here.
Okay. When you go to this character, d equals 0, and then you create the string builder over here, what happens when you do an append on d++ is you're taking the character and you're converting it into a number, adding 1 to the number, and then increasing the character list. So all of these characters were generated by counting out to 127. These are the first 127 characters in the char array. So when you're adding 3 to A, what you're going to come up with is a D. And when you add 3 to B, what you come up with is an E. So by adding 3, what you're doing is you're doing the Caesar cipher by a simple substitution. And when you're subtracting 3, you're doing your decoding in just the same way. How's that grab you? Good, right? Here, I'll show you another one. Let's assume for the moment that what we really want to do is say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So let's do that. We'll encode it, and then you'll see we're adding 3 has really change things in a very small way. When you have sequential characters like this, you will be able to see right away what adding 3 does. Right? So the ciphertext is essentially taken the first 3 characters and just shifted them. That's all it does. It's simple text, right? And why are there curly braces after Z? Well, because if you look at lowercase z, what comes right after is these curly braces. So adding 3 just caused a simple shift. Any other questions? No? Really? So let's see if we can do a quick review of the wrapper classes. A char is different from a character. What's the difference?
Char is generally used for non-numeric data type non-numeric data type, but character here is considered as one string.
Okay, I'll turn it into a char with a lowercase c, and then we'll run the program again. Runs just fine. There's no difference. Character is the same as char. No difference. Is that right? Why do they have 2 different things if there's no difference? Well, a difference that is no difference is no difference, right? A difference that's not different is no difference. So if char and character both work the same, there must be no difference. Does nobody want to challenge this statement?
There will be difference.
There must be a difference. Yes, I think so. What do you suppose the difference is? I feel like Yoda waiting for Luke Skywalker to lift up the spacecraft from the swamp, right? And then now my ears are drooping. So, yeah, as a result, I would say this, that a character is a reference data type, and a char is a primitive data type. So an array of char is an array of primitive data type, and every element in an array of primitive data type is the same as every other element. So that means you have a homogeneous vector of primitive data types when you have an array of any primitive data type. So if you have an array of byte, every element in the array of byte is a byte. If you have an array of int, every element in the array of int must be a int. Thank you. An array of char, every element must be a char. So as a result of these primitive data types, we know that there are no methods associated with char. However, that is not the case with character. If you take a char and promote it into a character, you now have a whole host of different interesting and wonderful methods upon which the char can be examined. And that may be of great importance to you. For example, let's assume that you have, I think we need a new example. Let's start. I like what I wrote. I don't want to change it, so we'll do another one. Char versus character. Okay. So now what I'm going to do here is I'm going to make a little method for main, and then I'm going to write char c equals quote h, end quote sem. First thing is I'm using single quotes for chars. I use double quotes for strings. Right now, let's do this. C dot. And it doesn't look like there's too many methods associated with it. That's it. But what if I said, aha, character ch equals new character of c. Now I've taken the primitive data type c and promoted it into the reference data type ch. Ch dot, I can convert it to a string, I can get the value, I can compare to, I can determine all these different interesting and wonderful things. I can find out if it is a digit. I can determine if it is a letter. I can determine if it is lowercase. I can determine if it is uppercase. I can do all these different interesting and wonderful things which I could not do before when it was just a plain, ordinary char. So all of these different interesting and wonderful operations are available to me. Suppose I said to you, well, let's see, I've got a person, and I said to them, please enter a number between 1 and 10. And what they entered was a string. And I'll call it a number. And it's equal to, I don't know, 9. That's a number between 1 and 10. How do I take that number and convert it into an integer? Integer n equals number. It doesn't work. Why? Well, because a string is not an int. So what do? They typed in, I said, please enter a number between 1 and 10. They type it in, I read in the string. Now I need to turn that string into an int. What do? Do what now? Parse it. Yeah, I could parse it. But if I know I want to parse it, why not go to the integer dot get value? No. Integer dot parse int. And then put in the number. And now the wrapper class integer has provided me with a static method for parsing. So now I've got int. I should be able to print it, quote, n equals, end quote, plus n. And what do we get? It should print out like 9 or something. You guys have a question back there? Yeah? No? No questions, just chit-chat? Okay. So now suppose somebody said, please enter a number between 1 and 10, and they put in 9.9. That's a number between 1 and 10. Isn't it? Yeah, sure, you betcha. Yep, that's between 1 and 10. So let's do that.
But it's not.
It's not an integer.
Yes.
Oh, so what kind of error do you expect?
Float.
It's going to give me a number format exception at runtime. That's very good. So if you type in bleh and the computer goes bleh, that's because you're not supposed to type in bleh. So if you don't like this number format exception at runtime, what is this thing, exception at runtime? What can I do about this? How can I try to catch that exception and recover nicely so I don't have a problem? What is an exception? Can you divide by 0?
No.
No? But I want to. What if I really want to? Well, how about if you really want to divide by 0? I could probably find a way to do it. But let's get past this thing here first. I've got this parse int. It doesn't seem like it's working. Let's do the following. I'll do double dot parse double. And now this has to be a double. And now I've converted 9.9 into a double. I can print it, and we're good. And we can get to the point of dividing by 0 a little bit later. How would we divide by 0? You can do that, right? Suppose I said n divided by 0. And now we run it. That sounds like fun. Let's divide by 0. I like doing it because I'm not supposed to. Oh, it's infinity. Wow, it's not even supposed to be a number. It's infinity. Holy mackerel. So you can divide by 0, and the answer is infinity. I thought that your eyeballs turned black and they fell out, but that's because I learned math on the street. So as a result, the dividing by 0 is okay. Java likes it. It's just infinity. Wow. You say you can't divide by 0. I just did it, and the answer is known. I don't even think it's supposed to be known. But Java likes it, so there. I thought it should be at least not a number, if not divide by 0 exception at runtime. But there it goes, dividing by 0. Happily dividing by 0. And giving us answers. Oh, I have a question. Whenever I got into an argument with my sister, I would say infinity plus 1 times. So I just want to make sure that's more than the other, because I wanted to win that argument. She probably doesn't care, because she doesn't know I'm telling you about this argument, but I was always winning. So let's see if I can add 1 to infinity. I expect... Oh, wait, it says 1 infinity. So what's going on here? How can you have 1 infinity? You see, plus is it's doing divide by 0, but the plus is doing concatenation first. So if I really want to win the argument with my sister, oh, this is getting silly, too silly even for a Java class, but we can do it anyway. So now I'm going to add 1 to infinity because I really want to. First of all, I'm not supposed to be dividing by 0 in public. And second of all, 1 plus infinity is still infinity. Darn it, I thought I was winning this argument. So as a result, I'm having a thing called infinity contagion. Because once it's infinity, everything that you do to it becomes infinity. I can multiply and add and take sine and cosine. Ooh, I haven't tried that yet. Let's take math.sine of infinity. Do you suppose that can be done? I'm very interested to see how Java handles divide by 0. I think this is fantastic. I didn't know it could do this. This is great. I've got like the new math. Not a number. So that's interesting. I thought if you took the sine of infinity, it should be infinity, but now we see it's not a number, which is actually kind of a satisfying result. So now I'll have not a number contagion. Anything I do to not a number should also be not a number, which probably includes dividing by 0. So if you divide not a number by 0, is it infinity or not a number? I actually don't know, because I don't normally do these stupid things. But actually, it's not all that stupid if you think about it. You really want to know. So divide by 0 is not always infinity. It could be not a number. Depends on the context. That's interesting. Well, don't do this at home. No, actually, it's okay to do it. It doesn't break the computer or anything. So we have these wrapper classes, character. We have other wrapper classes called double. And notice double is with a capital D as opposed to double with a lowercase d. So they sound the same when you say them in English, but in fact they are different things because this double is not a primitive data type. It's a reference data type, one of the wrapper classes, which gives you static methods for parsing strings. Same thing with integer and byte and character as opposed to char. Short with a capital S, long with a capital L. So probably all you really need to know is if you typed long with a capital L and then a period, you can do parse long. And that's pretty long. And the output should be a primitive data type al long, which you can then print as L. And there you have it. What do you think of that? So, how about those exceptions? We saw these interesting things going on where exceptions occurred. I believe what happened here was you said, please enter in a number between 1 and 10. And then the person said, bleh. What will the computer do? I think it's going to be some sort of a number arithmetic format exception at runtime, because bleh is not a proper number. Number format exception. Yeah, that's not a number. So what can I do about this? That's a very interesting question. I was wondering about that. What happens if I prompt the user for a number and they type in bleh? Can I just say, okay, the program dies, haha, rerun it? Or can I recover gracefully and say, sorry, bleh is not a number. Are you sure you want to type bleh? And try it again. So maybe I could do something like this that kind of looks like a number but really isn't a number. For example, 1024. That sort of looks like a number because it's got the comma. Java will be unhappy with it, right? So even a user who is not the pathological adversary could assume, I think rightfully so, that a comma is a perfectly legitimate demarcation, and that causes a number format exception at runtime. And so what do? Well, one thing you could do is you could try to guard the input. You could check to see if the number has any commas, and if it does, then replace them. Or you could just say number equals number dot replace quote comma with comma no quote. I guess you got a problem here, right? It's not working. He won't take an empty literal. That's a problem. What if you try and put in a null? Won't do it. What if you try and put in quote comma? That he'll do. So if you do that, you can just strip out the commas if somebody puts them in there. That's legit. It's still a number. And maybe it'll parse it now. And it'll avoid that nasty looking arithmetic number format exception at runtime. And it works. That's pretty good. So now I got another question for you. Suppose your pathological adversary decided to put a plus sign in there. Man, it's a problem. I don't think it's going to like it. Oh, he likes it. How about that? What if he puts in some trailing spaces? Ooh, that's pretty good. I like that. Trailing spaces. That could happen, right? It's a text field. You could have carriage returns and trailing spaces and all kinds of interesting and wonderful. Oh, likes it. Likes it. Of course, if he puts in really wacky stuff like this, I don't think he can help. Right? It's no good. So what do I do to try and catch these errors that might occur on input? I can guard the input by doing as much protection and substituting and trimming space and looking for commas and doing all these. But if somebody really types in garbage, there's nothing we can do about it, right? Stop. So what should I do? Now we're into chapter 9. No, chapter 10. Exceptions. Number format exception at runtime. What's an exception? Kind of an error, right? Yeah, and in fact, it's a very specific kind of error. And what you can do in Java is you can create what's called a try-catch statement. And so what you can do is you can select the offending area, which is right over here, and you can surround the code with a try-catch statement. And the try-catch statement can do something to try and recover. For example, it could say, well, if this doesn't work, then we'll say let n equal, 90 or something. Give it a default value. And you could even print out a warning. Oh, that's not good. Found plus number and replaced it with 90, or just say ER. But at least things can continue, and instead of printing out the stack trace, you can just continue to do your operations. So when an exception does occur, gesundheit, maybe we can try and catch it. And we see now there are two more reserved words here, try and catch. And look, it says, aha, I found some garbage, and it's an error, but I just used some default value and continued execution gracefully without having the main terminate abruptly. And so what we've got now are what I would call reserved words in Java, try and catch. You can't use them for variable names. You can't use them for class names. You can't use them as identifier. They're reserved for the language. Darn it. I don't know how to turn this off. I'm going to have to pull the battery. I like doing that. So what I'm thinking is the try-catch statement is something that we should learn a little bit more about. And there are a few different kinds of exceptions, but the two main exceptions are the caught and the uncaught, right? The runtime exceptions and the ones that subclass the exception class are the ones that you have to catch versus the ones you don't have to. So dividing by 0, that's a runtime exception. A parse format is a runtime exception. You want to try and open a file for read, that's an exception you have to either throw in your clause or try and catch. And so what we'd like to do is look at some exception examples. So here's somebody trying to create a new file, and here's a file input stream, and now we're going to try and do some division by x, whatever that may be. I think we better start from scratch on this one because that doesn't look like a very good example. Let's make a new Java class, and we'll give it a nice name. Let's call it simple exception. And in my little simple exception, I'm going to create a file, Alt-Enter. And now, this is probably the first time we've seen the file data type. The file data type is a reference data type which exists in the java.io library. And we're going to give it a name. We'll call it new file. And we'll call it foo.txt. And now what I'd like to do is I'd like to get a file input stream, FIS, equals new file input stream. And we'll put file in there. And he's got a problem. First of all, what's a stream? Any ideas? Stream? A stream, go ahead. What is it? A flow of information. That's pretty close. It's an unformatted sequence of bytes. That's what it is. And you can have an unformatted sequence of bytes going into your program or an unformatted sequence of bytes coming out of your program. And what you're doing here with a file input stream is you're getting ready to read an unformatted sequence of bytes from a file. You can format them as characters. You can format them any way you like. You can format them as objects. But in this case, they're just formatted as bytes. And Java requires that you have access to the file and that the file must exist. Now, if you try to open up the file and you don't have access or the file doesn't exist, then you have what you call an I/O exception at runtime. And that's what we're being complained about here. He's saying I can either add a try-catch statement or I can add an exception to the method's signature. So if we start with the try-catch statement, we can see, we can try and open up a file for read, and if the file is not found, then what we're going to do is we're going to print out a stack trace and stop the program. So let's give that a try. Yes, the system cannot find the file. So now let's start off by saying I'd love to know a little bit more about this file. So let's print out the file and see if there's a nice string representation of that file. I'd like to get a fully qualified file name with all the directories. But all he did was he printed out foo.txt. So that's not good. Let's see what else I can do. I can get the parent file, get the absolute path. That sounds good. I want to know the absolute path to this file. I could just type in the absolute path, but I think it'd be better if I knew the absolute path, and then I could just create this file and make sure it exists. And he says it's in J for P, foo.txt. So I'll just go in to my little command prompt, and I'll go in and I'll make up my own little file. This is a test of my little file. And what we'll do is we'll save it, and then we'll type it. And there's my little file. And so now it should exist. I think it exists. And there it is. How about that? So now I've got a file input stream, and I'm catching the file not found exception, but I really don't like the way this looks. So what I'm going to do instead is I'm going to wipe out this whole try-catch statement, and I'll just put in the file input stream and go back to this alternative that he gave me, which was to throw it in the method signature. So now I've got a main method which the Java virtual machine will invoke, and if the file is not found, then it'll just kill the main method. So let's try that again. It should be able to print out the absolute path name of the file. And then I think maybe what I'd like to do is see what it does when that file really does not exist. I think that would be very educational. So I'm thinking it should throw a file not found exception at runtime. So throws is another new keyword in the Java language. So I've got try, I've got catch, and I've got throw. And so when an exception is encountered, you can try to catch that exception, or you can declare it in the throws clause, which allows the exception handling to be deferred to the calling method. Isn't that interesting? So now I've got this very interesting sort of exception going on. There's the throws. There's file not found exception. Suppose I don't like this exception, this file after I see it. And I think, this file is not a good payroll file, and I wanted payroll. And so if it's an invalid payroll file, I'll throw an exception. So I'll just say if invalid of FIS, then, and how will I know if it's invalid? I don't know yet. Then throw new exception. Oh, I know, I could throw a new file IO exception, or even file not found exception. Because I'm already trying to catch that. I'm saying bad file. Bad file. Naughty file. And now, how do I know how a file is invalid? Well, I'll create the method invalid, which returns a Boolean, and I'll just have it return true for a good time. So now I don't know yet how I'm going to implement the test to see if the file is valid or not. But presumably I can guard the data processing so garbage doesn't come in, and therefore garbage doesn't have to come out. Let's see if we can do a run over here now. And look at that. Bad file. And it even has the string in here to let me know, hey, yeah, that's a bad file. So, I don't know. Is it really a file not found exception if it's a bad file? Not really. It's just a bad file. So maybe it's a different kind of exception. It's a invalid payroll exception, for example. So I can create my own exception. Here's a class called invalid payroll exception, and it extends the exception class. Huh? That's pretty good. So now instead of throwing file not found exception, we'll throw our own little exception called the invalid payroll exception, which is really a kind of exception, just like the file not found exception, but with a difference. It's our own little exception. But he's got a problem here. He doesn't take the string. So maybe I could subclass file IO exception. What's it called? Oh, the file not found exception. And then when invalid payroll is invoked with a string, it calls super of S. So now it works just like a file not found exception. And what does super of S do? Any ideas? Super? We've seen super before, right?
Superclass constructor.
Yes, calls the superclass constructor. Absolutely. So now if file not found is going to contain the string representation of the message you'd like to pass back to the user's console, in principle, you should see that when you throw the new invalid payroll exception. So you can create your own exceptions. So now let's assume that you have a job. That's a good assumption. And your job is to check credit card numbers with the merchant with back-end logic that runs on the server. So when the credit card number is not correct, you throw a credit card not found exception at runtime. So now your new credit card exception can be thrown, but you're not exactly sure what's going to happen from the caller's point of view. Because if the caller is generating HTML to the browser, the one thing you don't want to be doing is putting up a dialog box on the server. Because the person who's running, Amazon and doing a shopping cart and hitting buy, 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 will never see the dialog box that's coming up on the server going, bad credit card, bad credit card, bad credit card. Right? You have to let the person who's generating the HTML see the credit card not found exception and then tell the user, look, you've got to change how you do purchases here on this website, or else we cannot let you buy your goodies, which means commerce must stop. Right? So if you're trying to give the user a kind of an experience, you may not even be generating HTML. Maybe you're generating JavaScript with animations that have the big, skull and crossbones that says, lousy credit card, deadbeat, get off my website or something, right? Something more appropriate, I'm sure. You can design whatever you like. So the file not found exception handler, right, is someone who's going to be designing the graphic user interface that gives the feedback to the user, because you don't know if the feedback to the user is HTML or JavaScript or on a cell phone or coming off of some kind of iPhone or Android, or maybe it's done in Swing or AWT or SWT. Who knows? Anything could happen. And maybe just prints it out on the console and that's enough. But at some level, the business logic in the back end has been separated from the graphic user interface. And they're arm's length away from one another. See, the arms are long. So now, as a result, we have this very interesting technology behind the business logic for catching exceptions. I'll give you an example. They had this rocket in the Space Agency called Ariane 4. Ariane 4 was a booster rocket that they used to fire off from New Guinea. They decided they needed a bigger booster rocket for bigger payloads, so they went to Ariane 5. They took the guidance computer out of Ariane 4 and put it into Ariane 5, and it had an overflow, arithmetic exception at runtime. But instead of trying to catch it, they just let the guidance computer crash. And so as a result, they had to what they call self-destruct. The Ariane 5 booster rocket, which including its payload and the booster rocket, was like a $500 million loss for the European Space Agency, all because they weren't running Java and catching their exceptions. So it's possible, even in aerospace, to see the ability to try and catch these exceptions and then recover. Why did it overflow? Because they built the timer in the Ariane 4 booster guidance computer to only accommodate a booster fire that went for so long. Boosters that went for longer, the bigger boosters in Ariane 5, overflowed the register at runtime and caused the whole thing to crash. Everybody had a bad day then, all because they didn't take this class and learn how to try and catch exceptions. It's true. So these exception handlers are very important. So what happens when you find a caught exception? Well, you either have to declare it in the throws clause of the method, or you have to surround it with a try-catch statement. So if I remove the throws clause here, now I've got to try and handle the exceptions, either the invalid payroll exception or the file not found exception at runtime in the local try-catch statements. And you can do that either with two separate try-catch statements or one compound try-catch statement, because now when you surround with try-catch, see if I can do this. He shows this as a file not found exception, But if you were to change this from just a regular exception, from file not found exception to exception, what would happen? He doesn't like it. Right? Why is that? Because you still haven't tried to catch the invalid payroll exception. So let's make an invalid payroll exception completely different from a file not found exception. Get rid of the try catch block. And surround with try catch. And now we've got another exception that could follow it, right? He says it's unhandled. So now I've got two sequential try-catch exceptions. This one where we have to handle the file input, the file not found exception, and this one where we have to handle the invalid payroll exception. Two different exceptions. Let's see if we can run them. So then the question becomes, well, what happens if you don't have any try-catch blocks and you've got these two completely different exceptions that can be thrown? All right, I can remove these things. I'll remove the try-catch block here. I'll remove the try-catch block here. And now, I think maybe what we can do is we can declare this in the throws clause. And we'll add the invalid payroll exception also to the throws clause. And now when we look at the throws clause, we see, aha, there are two different possible exceptions which could be thrown by the main method. One is the file not found exception, and the other is the invalid payroll. So you can declare one or the other, or both, in the throws clause, and put a try-catch block around one or the other, or both. And in fact, if you think about it, if you took out the throws clause completely, you could surround the code with a single try-catch block instead of two. So now if you do code surround with try-catch, now you've got two different catches with a single try. So instead of having try-catch and then try-catch, you could have try and then catch-catch. Or you could have try-catch and then throw, or you could have a throw and then a try-catch. So you've got your choices. It's a lot of flexibility. And a file not found exception is being treated separately from an invalid payroll exception because they're two completely different errors. The file could certainly have been found, but perhaps it's not a valid payroll. What do you think of that? Slick, right? Exceptions are interesting. So these are all what are called the caught exceptions. Anything that subclasses the exception class is a caught exception. But then there's another kind of exception called the runtime exception. And on those, you almost never have to put in a try-catch block. But, as we've seen when somebody types in bleu during the parsing, you can get a number format exception. You could have a divide by zero, an arithmetic error exception. So there's all kinds of interesting and wonderful runtime exceptions. And these runtime exceptions, I can give you some examples of. Here we're dividing by zero, and we're trying to catch it. But before, when I tried to divide by zero, he said it was infinity. I don't know who decided that dividing by zero should be infinity. That doesn't seem correct to me. that seem correct? So what happens if I go in here and I just say, I don't try to catch it, if I just divide by 0? Because I really want to. I really do. I can divide by 0 without trying to catch the exception. You can see that right here. Java likes it. Oh, arithmetic exception at runtime. Thank goodness. For some reason I thought Java was going to tell me it's infinity. Right? Because before it was infinity. And now it's arithmetic exception at runtime, dividing by 0. That's what I want to see. Right? Because you're not allowed to divide by 0. I know, because I learned this in school. And it upsets me greatly when Java says it's okay to divide by 0. It's not correct. Right? Nobody should be happy with this. Right? Because what's the answer when somebody says, and divide by 0? You can't because it's undefined, right? You don't say you can't because it's infinity, because that's not correct, right? And you don't expect the Java compiler to tell you that it's infinity. You know, happily dividing by 0 and generating infinity. That's not right. Shouldn't do that. Now, maybe I could try and catch the first division by 0 and then throw the exception later. I suppose that would be legit. But if it tells me it's infinity, I'll just freak out, you know. So it's a you can try and catch your runtime exceptions. You don't have to. If you don't catch your runtime exceptions, it will stop the thread of execution. The thread of execution that's doing the runtime exception. You could have multiple threads of execution, some of which stop as a result of these sorts of runtime exceptions, and others which keep going. We haven't talked about multi-threading yet. In this case, it's stopping the main thread of execution, which just stops your program, stops it dead in its tracks. So what do you think of that? Good, right? So exceptions. That's chapter 10. Yes, it is. And you can read all about the throw statement and the throws modifier. Throw and throws are different. If you go on to page 128, you'll see the difference. Right? Throws goes into the method signature. So what you can do in here is you can say throws an exception. Or what you could do is you could create your own exception, class exception. Oh, I know how to do this. How about this? Divide by 0 exception. Divide by 0 exception. Subclasses have the exception class. How's that? And what we'll do, instead of using throws, is we'll say throw. T-H-R-O-W. A new divide by 0 exception. How's that? So throws is different from throw. When you're in the context of the program, you can always throw a new exception. You can even create your own. But when you're looking for the signature of the main method or any method that's doing the invocation, that's where the throws clause belongs. Suppose I wanted to throw both, a divide by 0 and an exception. What would I do? Well, I would put the divide by zero exception in there with a comma. And you can throw as many exceptions as you like. And he found the divide by zero exception. Even after he gave me the warning, danger, dividing by zero. So what do you think of that? Good, right? So where are we here now? Chapter... Are there any questions about Chapter 9? No? Are there any questions about Chapter 10 on exceptions? The one we just did? Nothing? Okay. So we did try, catch, we did throw, we did throws. There's another term within the try-catch block that I didn't cover, and it's called finally. Finally is a reserved word in Java, and it's used as an optional part of the try-catch block, and it always gets executed. For example, if somebody says, I will buy you diamonds and I will buy you coffee. And then you say, well, what if you don't have enough money in your credit card to buy me diamonds? Well, I'll still buy you coffee. Right? So finally, always gets executed. So, you got coffee. No, you got Java. That's it. Yeah, you got Java. Coffee's the good example because it's Java. So even though you're throwing the divide by zero exception, do you suppose the finally will be executed? And the answer is yes. You got Java. So why? Why does this happen? Because if you're in the middle of something where there are many open files, and you try and open another file and you get a file not found exception, if there's a finally in there, you can close the other files and make sure they're not corrupted. You can close the other input and output streams to make sure they get flushed. You can release resources like serial ports to make sure they're not held open so that when the program runs later it says, sorry, the serial port is already owned and you can't use this anymore. And therefore you have to reboot the computer, right? You have to really release these resources or else the activity of your program could cause deadlocks in the operating system, which may only be resolved by intervention from the system administrator. So things like a magnetic tape drive. If you're getting an exception over here, you better unassign that magnetic tape drive so others can use it, or else they're going to be angry at you because you have this resource they cannot use. So this is sort of an important factor. It lets you finish up. It lets you do your housekeeping. It lets you buy your Java. So finally, I rarely use it, but you will sometimes see it. And so it's one of those little things. It's a subtlety in the language. It always gets executed. And that wraps up that chapter 10. Let's see if I got everything. So what's the difference between string builder and string buffer? String builder and string buffer?
Both are literally same, but some
They're both reference data types.
Yeah.
That's true. But that's their similarity. They both let me modify strings surgically. Strings are immutable, but string buffers and string builders are not. They both have very similar methods, but they act differently. The string buffer is thread safe. We haven't talked about threads yet. The string builder is not, so it can run a little bit faster. So if you're in doubt, you can use string buffer, especially in a multi-threaded environment, but string builder will generally be faster. And that gets you right out to chapter 10. How exciting. Chapter 10. All done. Any questions about chapter 10? Okay. Any questions about chapter 11? No? Good. Any questions about chapter 12? No questions? This is great. All right. Midterm tomorrow. Oh, any questions about the midterm tomorrow? Since nobody has any questions, we can just finish the course. I like this. This is great. You make my job easy. So, no questions. Any questions about the book? No one has any questions. I don't even know why I bother. Okay, so I was thinking that maybe we should assign some reading. And there's also a homework, right? So the homework, I don't know, if for those who came in a little bit late, I'm changing the style. I just want to sort of make sure you guys are understanding about this new style of homework. Normally, it's A, B, C, or D, and you pick one. We call that multiple choice. This is different now. This new one lets you pick more than one letter. So the answer can be A and C. And in fact, if you don't get them both, it's wrong. So that means you have to read all the letters, and you have to be careful when you check. It's not a radio button that's mutually exclusive anymore. You've got to pick multiple letters. You know, it used to be true or false, right? That was easy. I'm a computer engineer. I'm here to tell you everything should be true or false. Everything. But in fact, in real life, that's not true. Sometimes it's multiple choice, and we're used to that. But this is different. And the reason why is because this is how Java 2 certification examinations are administered by Oracle. So I decided to go with this style. I don't think I have any reason why we can't discuss packages a little bit. I think it's a very good idea, right? So what I'm going to do is I'm going to take a different approach to my discussion about packages. I'm going to show you what is being output. This is my little Java for Programmers code, right? And what do we see here? There is jars. Is there a question in the back? We see some output file where the class files go, and we see some source code. So let's take a look into the, I know, I'm going to run my little editor. I use an editor called Emacs. Has anybody ever heard of this editor? It's free. And what I'm going to do with my little editor is I'm going to use it to explore my file system. So here's my source code. And now what I see here is this thing here called main.java. And it's got this element in it called hello world. And it has no package statement at the beginning. That means it's in what's called the default package. So the top level package is the default package. Okay. Here's something called book examples. And in book examples, I have these folders. And here's one called Chapter 9, Wrappers and Strings. And in Wrappers and Strings, I have this thing here called string example, and then there's character example, and then there's character versus char, or char versus character. And I see it's in a directory called src book examples chapter 9 wrappers and strings. And when I look at the package name, I see, aha, it says book examples dot chapter 9 wrappers and strings. So the package statement is a reflection of the relative folder name. That's all. That's it. Now, when you go to compile, what will happen is you'll create bytecodes which are also organized by folders, and they will be findable by the Java virtual machine during the dynamic loading of runtime by using the actual fully qualified class name. So the class name of char versus character is book examples dot chapter 9 wrappers strings dot char versus character. And you can see that by creating a, probably shouldn't be doing this in the editor outside of IntelliJ, but we'll do it anyway because what the heck. Public static void test system.out.println hello. And now I've got a fully qualified class name mechanism to invoke the test method. And I can use that in my main by saying something like book examples, oops, got to spell it right, it's case sensitive, chapter 09 wrapper strings dot char versus character dot test. And so what I've done at the bottom is I've used a fully qualified class name which includes all of the packages to identify uniquely the char versus character test. So now if I save it, if I'm lucky, IntelliJ will pick it up. And it did. It looks like I got something wrong here. Is it, oh, it's wrappers. I left out an S. Wrappers and strings. No? What did I do here? Copy. Paste. There it is. Must have spelt it wrong. So now I've got a fully qualified class name preceding the method invocation. And I can use that from anywhere in the system. In other words, book examples dot chapter 9 wrappers strings dot char versus character is a global identifier which allows me to have access to all of the static members in this class without making an instance of it. And so in theory, at the end of the day, if it doesn't throw some exception, it should print out whatever test was printing. Hello. Yeah, and it does. So what that means to me is I can cut this out and I can put it anywhere. I could put it over here next to, somebody wrote a thing called Fred and Wilma. So I'll put it in the beginning of Fred. Do you all know who Fred and Wilma are? No. No, never heard of them. No. You ever hear of the Flintstones? No. It's a cartoon for children, and it probably didn't run in your country. But Fred was always having some argument with Wilma. Did you ever hear of Jackie Gleason and the Honeymooners? No? You don't watch television. Okay. So here is hello being printed, and it says hi Fred, hi Wilma. So we've got a fully qualified class name, which includes all of the packages. You can use fully qualified class names anywhere. So for example, if you wanted a file, now he says java.io.file. He's wondering. So you hit Alt, Enter, and what is he doing? He's trying to import the class so that the class can appear without using the fully qualified path name. But if you chose not to do the import statement, you could just type it out. You could type, I want java.io.file. And now he's fine. Well, probably got to give it a name that's unique. So if your goal is to gain access to all of the classes in the java.io package, the import statement will do that. So here I am up in the Fred package, and I can, right after a package statement, put in an import, java.io.star. And now, with Java.io star opened, I have access to the file, and it's very clear that that is the file which resides in the java.io package. So the import statement gave me access to the file data type, which is a reference data type, which has a very nice looking piece of documentation telling us all about files. I used Control Q to bring that up, by the way. And if I wanted to learn more about the class, I could use Control B. Cannot find the declaration. Really? Oh, here, Control B. And then we can actually see the class. Here's the file class and all of its source code. So Control B allowed me to go to the declaration of the java.io file data type. You guys got a question? I'd love it if you asked me a question. Nobody here ever asks questions. How come nobody asks any questions? I say chapter 12, no questions. Chapter 13, no questions. Anything questions about the book? No, no questions. Okay, we're ready for the final. So, how's that grab you about the packages? So you got packages are really nothing more than directories that help you organize your namespace. Gaining access to classes in that namespace for that subdirectory is available to you either by using an absolute, I'll call it fully qualified class name, or by using an import statement. Now in your import statement you don't have to use the star. You could import things one class at a time. So for example, you could import, hit space, and you can see everything in the I.O. package. And you can go right on down the list. All this stuff is in the I.O. package. So you could say, geez, you know what? I only need one thing. I'll just import the file. And that's sufficient. But then later, if you want to throw a file not found exception, well, you'd better import that as well. So you may have to import everything explicitly if you choose to. What do you think of that? Packages. So let's see what happens to the output of the Java compiler. Here's the output, and here's something called production, and here's the J for P production, and somewhere in here we should find book examples, and here's the chapter 9 stuff. And look, there's the output, the byte codes. And if I run Emacs on that, I should be able to explore them. Here's the string example, and you can kind of see there's a not human readable, but interesting looking identifiers along with some binary, and those are the byte codes, the compacted byte codes, which the Java virtual machine will read in. It will read them in It will compile them down to the iron using the just-in-time compiler and give you good execution speed. And that's what a Java compiler does. It outputs bytecodes. And the bytecodes, if you notice, are organized according to a directory that matches the package name. So if you are in IntelliJ and you start refactoring by moving classes around, the package name can change. Let's see if we can do that. So here's a package, chapter 11 packages. Let's get out of chapter 11. I want to go back to chapter 9. There's good. That's good. So suppose I said to you, gee, you know what? I'm going to change the location of char versus character. So I'll do refactor move. Now I can move it from chapter 9 into chapter something else. Let's try chapter 10. So now if I do the refactor and I go to the top, you see, aha, it's now in chapter 10. And anything that had referenced it while it was in chapter 9 would be modified and updated with new imports so that it would reference it in chapter 10. All the dependencies would be updated. That's the wonder of refactoring. Refactoring allows you to change locations and reorganize your code without having to worry about breaking stuff. That's very important. And if you didn't like what you just did, you could undo the move, and now it's back to where it was. What do you think of that? Sweet, right? So now we've got packages. I think it's kind of an interesting idea. Why do I need packages?
It includes classes.
It includes classes. Well, that namespace. Yes, packages allow us to organize the namespace because otherwise every class would be known to every other class. And that's not necessarily a good idea, especially if you have different people in charge of different packages. So if I have a package whose name is lion, and I have another package whose name is Wuksung, I can ask Wuksung to develop some component of the system which is held as separate from the lion component. Now maybe Wuksung will work in the area of database because he's an expert at database. And Lion will work in the area of image processing because maybe he knows more about image processing. So then how do we work together? And the answer is, well, we keep our code in our own packages. I don't modify his package, he doesn't modify my package. And then we devise interfaces which enable us to communicate. And then once we program to those interfaces, we can actually work separately but together, right? Where the interface between the different packages can allow a simple facade, a design pattern which allows a simplified representation of what's going on underneath. So if you think about the facade design pattern, think about a car. A car is a simple interface. Steering wheel, brake, and gas, right? You can go into any car and it has the same interface. Could be sports car, station wagon, sport utility vehicle. They all drive the same, right? So as a result of a simplified interface, it doesn't matter how complicated engines are underneath. That facade gives you a level of comfort so that you don't have to relearn how to drive every time you change cars. So that simplified interface really saves you, right? And it will always work except when it doesn't. And the reason why it might not work is if you're in something that might be a mode of transportation that really isn't like a car. For example, in an airplane. In an airplane you have two pedals, but it isn't gas and brake. right? It's left and right on the rudder. So you try and use it for like gas and brake, and all you're doing is turning left and right, and it becomes very confusing. Plus, you have a steering wheel, but it doesn't just turn left and right. You pull back and you push forward to alter the air surfaces for the elevators. So as a result, you're a little confused. Airplanes are not cars, right? And it wouldn't be good for you to get into the airplane and try and treat it like a car, because airplanes go up and down and cars don't normally. What do you think of that? Packages. How about this? Import java.awt.star. What do you suppose that does? Say it again? Yeah, it imports the abstract Windows toolkit. And if you wondered what the stuff was, you could go through with a control space after you type in the period, and it will list all the different classes which are available to you. These all become a part of your namespace locally once you do an import with a star. All of these things are available to you. But if you said to me, well, geez, you know what? I don't want to import all that stuff. Well, now we've got multiple choices for the list, because how does he know which list you mean? So now when you do Alt-Enter, he says, well, there's a whole ton of the different lists. And if you import the class, I have a Java util list, a Java AWT list, IntelliJ has list, Android has list. You want list, we got list. And they all work differently. And they're all different data types. No two lists are the same. An AWT list and a Java util list are different. So here, if I use an AWT list, then look what happens immediately afterwards. I got a Java util list. Those are two different data types, right? Because a Java AWT.list is meant for display, and a Java util list is just a container of reference data types. Very different classes. And you can't convert from L to L2, right? If L is an instance of L2, and now what's his problem? L is supposed to be a new list, right? Here. Here, let's make it list 2. So what's he on about? What's wrong with this code? Oh, well, you need to put it in a main method for one thing. There. So if this is an instance of the list class, it'll type in it worked. Otherwise, these are different types. And they should be different types. Right? Because list is an instance of an AWT list. And if you wanted to, you could even prove it to yourself by printing out the actual class from which the list descended. List.getClass. And then you can do the same thing for the next one. Which is list2.getClass. And that should give you a fully qualified class name, which includes the packages. Oh, except it was null. Oops. I did it again. Something about this keyboard. It won't let me print the something's going on here. I want a left parenthesis, but when I type the left parenthesis, oh yeah, it did work. List is abstract and cannot be instanced. Really? Oh my gosh. What a pain in the ass. I'm not doing that. Sorry. Let's just leave that one as null. I think that's a little easier. I need something that descends from list. Maybe a new vector. Yeah, he's good with that. So a vector is different from a java.awt.list. That makes sense. And it says these are different types because a java.awt.list is not the same thing as a java.util.vector. Two different classes. So that's interesting. What were we able to do in order to get the fully qualified class names? How did that work? I mean, how was this able to even print that? Nobody knows, right? Well, I called getClass. So when you go to an instance and you call getClass, it gets the class from whence the instance came. So if an instance is like a cookie, then what you've gotten back is the cookie cutter. So this is telling you where that cookie cutter lives, which drawer it's in. And it's saying, well, I got this cookie cutter out of the java.awt.list, whereas this other cookie cutter is the java.util.vector. Completely different. Even though they were both cast to something called list, they're totally different reference data types. So that gives us a clue as to exactly where these things came from. You can't cast list into list2. You can't do this. List equals list2, right? Because why? They're incompatible types. He wanted a java.awt.list, but what did he got? He got a java.util.list. I said, well, I know what I'm doing. Trust me. Trust me. I know what I'm doing. There. Ha, I win. What did I win? I won the right to get a class cast exception at runtime is what I won, because what I just did was not going to fly with the Java runtime because these are different data types. They live in different places. They sound the same. They're both lists, right? How come I can't do this? Well, I got a class cast exception at runtime. That's why. Because a Java util vector is a different class from a Java AWT list. I know they both said list, but they're not. They're not because they really are different things. A vector is not an AWT list. Got it? Okay. That was my message of the day. So importing allows you access to similarly named classes, which can cause you to have what I will call a fruitful source of error. Right? You can get all these different class cast exceptions at runtime, and it can drive you absolutely nuts. But the only way that you're going to be able to get around it is to keep it straight in your head. These are different data types because they came from different packages. So when you've got these packages available and you start importing stuff and they sound similar but they're not the same, you can't start doing the assignments with wild abandon, because otherwise you're going to get these class cast exceptions at runtime. And believe me, this happens to me all the time. I forget which list is which. It's easy to do, even for someone experienced. So I guarantee you this will happen to you, unless you're exceptionally lucky. All right, so we did a lot. Today I think we did a lot. We got through chapter 9. We finished and covered exceptions. We went through runtime exceptions. We went through try-catch exceptions. We did the throw clause. We did the finally clause. We did the wrapper classes. We did the string buffer. We did the string builder. We did the Caesar cipher. Oh, how exciting. Right? Codes from the past. And then we did this little thing about packages and the import statement and the package statement. So all this stuff got done. I see you're putting stuff away, so you must be finished. So then I'm going to suggest the following. You've got yourself a homework assignment. Now you've got yourself a reading assignment, right? If you haven't read it already, chapter 10, chapter 11, and now for next week we're going to be covering nested reference data types. These are the most exotic parts of Java. And so I plan to cover them relatively thoroughly. And so we're going to have inner classes, inner interfaces, and all of these nested reference data types did not exist with Java 1.0. They only started them with Java 1.1, which happened sometime around 1996. So they've been around for a while. But they didn't start with them. And that's what I have for you for today. Hope you have a good evening. Thank you.